Welcome to the 8th video in this series on the history of astronomy. In this video, we're going to be finishing off the Islamic Golden Age, looking at its decline and its lasting legacy on modern-day astronomy, mathematics, and science in general. If you haven't seen the first video on the Islamic Golden Age, I suggest you watch that first, as this one directly follows from that one. So let's start off by recapping what was covered in that video. The Islamic Golden Age started with the translation movement by the Abbasid caliphs, in which essentially they were heavily invested in translating as many texts as possible into Arabic. Regarding astronomy and mathematics, most of that came from Indian, Persian, and Greek texts. Right off the bat, the Abbasid caliphs were sponsoring astronomers and mathematicians, who very quickly became the best astronomers and mathematicians in the world at the time. After adopting the Hindu numerical system, in a short period they invented algebra, modern-day trigonometry, the scientific method, and they built the first mural sextant observatories, which became a standard around the Muslim Empire. These mural sextant observatories allowed for astronomical measurements down to 1 arcsecond in precision, making Muslim star charts the most precise in history at the time. I'd like to make a correction from the previous video where I stated that Ibn Bajjah was the first person to suggest that the Milky Way was just a bunch of tightly packed stars. The viewer corrected me, telling me that actually this had been suggested first by Democritus from the Greek Golden Age. In the previous video, we also saw that the Arabs founded the field of optics. This was largely done by Al-Haytham with his book Kitab al-Manzir, which just translates to Book of Optics in Arabic. This book spread all around the world, and among other things contains the two most fundamental laws you'll learn in any modern-day course on optics: the law of reflection and the law of refraction, known today as Snell's law, but this was actually first discovered by Ibn Sahl 700 years before Snell. We're now at the height of the Golden Age, roughly around the 12th century AD, and now we start to see a bit of a decline. This is where we left off in the previous video. To be clear, this is just the beginning of the decline, and it's very gradual. The Golden Age does not end at this point. The decline happens for numerous reasons, one of them being the fragmentation of the Abbasid Empire, which happens within a couple hundred years. This now means that we have multiple states, each with their own priorities, and generally this means that sponsoring of science and research takes a little bit of backseat to other political priorities. Another reason for the decline is we start seeing a shift in ideology that is less favorable to scientific endeavor. The first hint of this comes with the polymath Al-Razi, or Razi, who is the first person we know of to talk about the scientific method, and he was a staunch follower of this principle. He applied it to everything he did, and he got into trouble when he applied this scientific demand for evidence to the Quran and the Hadith, in particular the Hadith, where he was very critical of these books, stating there is no actual evidence that any of these stories are true. Well, apparently this did not go over too well with the powers that be, as he later apologized and took back his statements. If you're enjoying this video so far, please take a quick second to like and subscribe, and if you'd like to help out the channel, there'll be a link to my Ko-fi page at the end of the video. You can also find it in the description. Now, where were we? You see, even though Muhammad had stated that there are no religious authorities, many of the rulers of these Muslim states were, at least in part, claiming that their legitimacy as rulers came through some connection to Muhammad, justifying their right to rule as the legitimate, divinely approved successor to Muhammad, often as a result of some sort of genetic tie to him. So, by questioning some of these religious texts, Al-Razi was actually, in some sense, questioning the legitimacy of these rulers. So he had to take it back, either because they just decided we're not going to fund you anymore, or possibly they threatened him with something worse. And apparently these threats were no joke, as later on Al-Biruni and Ibn Sina, who came on the scene after Al-Razi had died, and were also ardent advocates of the scientific method, wrote very strong critiques of Al-Razi's point of view on religion, as well as making scientific arguments for the validity of Islam. These writings were in stark contrast with their general attitudes towards scientific reasoning and demand for evidence that is found in everything else they wrote about. So this is kind of one of those situations where you're going, methinks thou protest too much. Seems like they're trying really hard to convince the caliphs that they don't like Al-Razi or his views on religion. Now, whether they were doing this in order to ensure their scientific funding, or because they were scared of worse threats, I don't know. The idea that these critiques of Al-Razi's views on religion are disingenuous is somewhat speculative, and yet, many historians have argued that all three of these guys were probably atheists. You have to remember that this scientific pursuit was not something that was initially part of the Arab/Muslim culture. It was something that was adopted under Abbasid rule from the culture of the city-states of the Silk Road when the Abbasids took on viziers from prominent families from these city-states. They're the ones who introduced this desire for scientific pursuit. And all three of these guys came from this culture. Eventually, we start to see a gradual shift away from a desire for scientific pursuit and towards the truth of Islam, to the point that some of these Muslim rulers even start burning their own books for not being in line with the proper Muslim philosophy. But this is more of a gradual and statistical shift. In the 13th century, we get the Mongol conquests, and in 1258, Baghdad, the center of scientific pursuit in the Muslim world and possibly even in the world, is sacked by Hulagu Khan. This is a major hit, as arguably the biggest libraries in the world are in Baghdad and they're all destroyed. The story goes that, according to survivors of this event, the Tigris River, which runs through Baghdad, initially ran red with the blood of its inhabitants, and then ran black with ink from all the books that were thrown into it. This is somewhat ironic, as the Arabs/Muslims initially started off doing the same thing, going around and burning and destroying all the libraries of the cultures, mainly Persian cultures, that they conquered. This is because the original Arabs had very similar culture to the Mongols. They were both nomadic people living in barren landscapes, and they survived essentially by trading and raiding. As nomadic cultures, they don't care about books, their priority is to travel light. It's not until much later that the Arabs/Muslims change their culture when they become rulers of large empires. Now, even though the sack of Baghdad is a major hit, it doesn't end the Golden Age, and in fact, within a couple years, Baghdad is rebuilt and scientific pursuit continues. But who knows what knowledge was lost when those books were destroyed. And they didn't just sack Baghdad, they sacked numerous cities in the Muslim empires, which had their own libraries as well. In one of these cities, astronomer Al-Tusi managed to escape, saving a handful of what he considered to be the most important documents. He then convinced Hulagu Khan to build him a new observatory, which is still around today. It's called the Marageh Observatory. I don't know if I'm pronouncing that right. It's in modern-day northern Iran. And the story goes here that Al-Tusi convinced him to build this by telling him that if he could predict the stars, people would worship him and everyone would listen to him. Now, generally speaking, the Mongols are not that big on funding scientific pursuit. But that's not to say they didn't do it at all. They did fund it, it just decreases during Mongol rule. But one thing that happens under Mongol rule, because they've conquered both the eastern half of the Muslim world and the Chinese Empire, a lot of scientific information flows now from the Muslim world into China. Eventually, the Mongol Empire fragments as well into what is sometimes called the Turco-Mongolic empires. This is because it's now a mix of Turkish and Mongolian people. The Turks and the Mongols are both nomads from the Eurasian steppe, so they have very similar cultures, so they intermingle quite a lot. And under Turco-Mongolic rule, we see further decline in funding of scientific pursuit. But that's not to say they don't do it at all. It just depends on the priorities of the ruler. For example, we have one local ruler named Ulugh Beg, who is a big fan of astronomy and builds an observatory in Samarkand, which also is still around today. As I mentioned, the decline is slow and gradual, and the final nail of the coffin of the Islamic Golden Age is not until the fall of the Ottoman Empire at the beginning of the 20th century. Now, around the time of the Mongol conquests, it has become widely apparent among Muslim astronomers that Ptolemy's model doesn't work. So there is a strong push to find a better model. Just to remind you what Ptolemy's model is, most people think it's planets go around on epicycles that go around a circle centered around the Earth. But actually, Ptolemy's model is more complicated than that. For one thing, even though it is geocentric, meaning the planets go around the Earth, he doesn't have the Earth at the center. He has it offset from the center. This is called the deferent, or sometimes the eccentricity of the orbit, not to be confused with the eccentricity of elliptical orbits. These are circular orbits, and the eccentricity for a circular orbit just refers to the offsetting of the Earth from the center. Ptolemy also has the planets not going at a uniform speed around the Earth. The speed of the center of the epicycle going around the Earth varies throughout its orbit. And it varies in such a way that were you to stand on a point called the equant, at that point it would appear to be going around in angular speed at a constant rate. So this is Ptolemy's model, and by the time we get to, say, the 12th, 13th century, we've had an accumulation of over 1,000 years of astronomical data, and possibly even more if we go past Ptolemy. And that, combined with the better precision of the Muslim astronomers, it is apparent now that this model doesn't work. So there's a strong push to find a new one. But even though the model doesn't work, it's not so easy to find a better one. And astronomers in the Golden Age are pretty much throwing everything they can at this problem. For example, Al-Tusi discovers something called the Tusi couple, where he shows that circular motion can look like linear motion and vice versa. So he tries to come up with a model based on this principle. But this is not the only thing they try. Muslims all across the Islamic world are trying pretty much anything and everything. They try eliminating the equants. They try eliminating epicycles. They try changing the eccentricity of circular orbits. They try elliptical orbits. Now, some of you who know something about astronomy will know that elliptical orbits are actually correct. So why didn't this work? Well, it's not enough to say we have an elliptical orbit. You have to say, how do things move around in the elliptical orbit? So even though they do try elliptical orbits, which by the way have been tried since the time of the Indians, they still can't come up with something that does better than Ptolemy's model. There's also questioning of whether the Earth is actually stationary. So they also try heliocentric models. They even try combinations of heliocentric and geocentric models. They basically try everything and anything, but they never figure it out. Even though they know Ptolemy's wrong, they cannot come up with a model that does better. The problem of planetary orbits would then get passed on to the Europeans, who based all of their astronomy, mathematics, and science in general off of the Islamic Golden Age. So we saw that the Islamic Golden Age started with the Abbasid Empire when they took on advisors or viziers from the Central Asian city-states of the Silk Road. Scientific and mathematical knowledge flowed in from this region, which is sometimes called Transoxiana, into Baghdad, and then from Baghdad all around the Muslim world. And eventually, and very slowly, all that knowledge trickled into Europe. And I say trickled in because it came in with a lot of resistance from the powers that be in Europe. And in this way, the torch of scientific pursuit was passed on to the Europeans. As I mentioned, the Islamic Golden Age is the foundation of European scientific pursuit, and its fingerprints can be found all over modern-day science. For example, that's where we get Arabic numerals from. Now, they originated in India, but they were spread around the world by the Muslims who had taken them on. That's why they're known as Arabic numerals. Europeans believed these numbers were invented by the Arabs. The Arabs also gave us algebra, modern trigonometry. Our modern-day trigonometry does not come from the Greeks, it comes from the Arabs. The system we use today is the Arabic system, or Muslim system if you prefer, which was built off of the Indian system. So if anything, you could argue it comes from the Indians, but the system we use today was developed during the Islamic Golden Age. The Islamic Golden Age also gave us spherical trigonometry. If you've ever taken a calculus or astronomy class, you'll recognize this spherical coordinate system, which comes from the Arabs. Now, it was based off of a system developed by the Greek Eratosthenes. It's also where we get the longitude-latitude system from, but it was further developed and standardized by the Arabs. And in fact, the terms zenith, azimuth, and nadir are all Arabic words, or I should say, Latinized garblings of Arabic words. And there's a whole slew of scientific terms that you may not realize actually come from Arabic, such as star names. Most stars in the sky have Arabic names, or more precisely, of the stars that have names, most stars don't have names, but the ones that do, most of those names are Arabic names. And the reason for that is Europeans built their astronomy off of Arab or Muslim astronomy. The Islamic Golden Age also spread infinitesimal math to Europe, Now again, the Muslims did not invent infinitesimal math. It was initially studied by the Greeks, the Chinese, and the Indians, but they further developed it, and from then it goes into Europe and lays down the foundations of calculus. Muslim polymaths did not invent calculus, but they did lay down the foundations for its invention. For centuries, European astronomers used Arabic star charts because even though they had started practicing astronomy, the Muslim astronomers were still better, and they were so accurate that many are still used today. We also get alchemy spreading into Europe, which is the foundations of modern-day chemistry, and we already saw that they invented the field of optics, which is then further built upon by the Europeans. And arguably, the most important thing, or one of the most important things that Europeans get from the Islamic world, is the scientific method. Muslim polymaths were widely read in Europe, going all the way back to possibly the guy who started it all, Al-Khwarizmi, who was known in Europe as algorithmi, which is where we get the word algorithm from. In fact, most of these Muslim polymaths were so widely read in Europe that they developed Europeanized names. The torch has now been passed from the Islamic Golden Age to the Europeans, and if you enjoyed this video and would like to continue this journey in the history of astronomy, be sure to like and subscribe, maybe leave a comment, and click the bell to be notified for the next video in this series, where we will be looking at the rise of European astronomy and science in general. And if you'd like to support the channel, you can go to my Ko-fi page, or you can just leave a super thanks. Thanks for watching, and hopefully I'll see you in the next one.